So this video is going to go over finding the area of a triangle where you don't know the perpendicular height, or where it's not making a right angle with the base. It's not a right angle triangle. So this formula will work for any triangle, whereas the one you normally do, like the half the base times the height, that only works when you know the perpendicular height, like that for example, so where it makes a right angle with the base. Or if it's a right angle triangle like this, then you can just do half the base times the height, because that is the perpendicular height. Okay, so sometimes you don't always know what that perpendicular height is, and therefore you have to use this formula here. So the formula for it is half AB sine C. So that means that you do half times A times B times sine C. So the fact they're all next to each other like that just means that we need to multiply them all together. The other thing to point out with this, so you can label your sides with like the A, B and C like we've talked about before, but essentially I think the easiest way to do this is, if C obviously here, that's the only angle that there is in this formula, so if this is capital C for example, we know that the side opposite would be little c, and so A and B always need to be the two sides that are making the angle that you know. So or you can think of it as the angle needs to be between the two sides that we know. So A and B would have to be these sides, or I could make it B and A, but the point is that you always need to have these two sides with the angle in between, or you could use, for example, these two sides with the angle up there in between, or it could be these two sides and then you'd have to use this angle. So I think rather than worrying about labelling it too much with A, B and C, I would just think of it as the two sides that you know with an angle in between. So we'll start with a nice easy one, hopefully. So here, look, you can see straight away, well, I've got two sides that I know and an angle in between. So it's just going to be sticking it into the formula up here. So half times 5 times 8, it really doesn't matter which order you do that in, multiplication doesn't make a difference. So half times 5 times 8, or you could have done 8 times 5, times sine of the angle between them, which is in this case the only one we've got anyway, and you would work that out on your calculator. So times 5 times 8 times sine 30, so that would be 10, and it would be centimetres squared. So sometimes you might get a decimal answer, it's just because sine 30 happens to be a nice number. So if we have a look at a slightly more complicated one then, so quite often in exams they do tend to be as easy as that actually, where you're just given the two sides with the angle in between. Now this question I'm just going to show you, because on this one you can see that you've got a couple of angles, and just for revision's sake, obviously you could work out that one up there as well, couldn't you, because you've got two angles in a triangle and we know that they all add up to 180. So it's always worth just checking that, because sometimes that could be helpful in an exam. It's not actually going to help us for this question, but sometimes worth just bearing that in mind. So we need to remember with the area formula, so I'll write it down again here, so half AB sine C, and the main thing is just thinking, right, well if you went for the 70-degree angle, well, you need the two sides either side of it. I know that's 6, but I don't know that side, so that angle is no use to me at all for finding the area, and it's going to be this one up here that we need to use, because I do know the two sides either side of that 50 degrees. So it would just be a half times, and again you can times these in any order you like. I'm going to go for 6 times 10 this time, and then it'll be times sine 50. So it's just making that point that the angle needs to be between the two sides that you know. So it's not really that useful for you to know the answer, but it would be 22.98 centimetres squared. So just some other variations on it. There's nothing particularly any more tricky with it, but sometimes things that they could just throw in there. So with this kind of triangle, I haven't actually said it, but the fact that this side is the same as this one suggests it's an isosceles triangle, doesn't it? So if it's an isosceles triangle and we know this side is the same as this one, well I can straight away say, well this side is going to be 7, the same as the other one. And if it's an isosceles triangle, I can work out my other angles. Now if we want to work out the area, and this is our formula, we know that we need that angle to be between the two sides that we know. So here are the two sides that we know. This is the angle that I want to use for this formula here. So I need to work out this angle here. Now, if it's isosceles, this angle here will be the same as this one. that makes 140. I need to make 180 for a triangle, so this one must be 40. So it's just bringing in angle facts that you would have done in younger years. So now I'm going to use my formula. So we need the two sides that we know, angle in between, so it'll be a half times 7 times 7 times sine 70. So I'm not going to work that out this time, but that's what you would need to type in on your calculator. And the final one, again, just a different thing that they might do. Lots of people then would get stuck on this because it's an equilateral triangle. So if it's an equilateral triangle, you've got to think, well, what do I know about equilateral triangles? Well, I know all the sides are the same. So I know that's going to be 8, 8, 8. So thinking about your area formula, well, if it's a half AB sine C, we know lots of lengths, so that's going to be fine, but we don't know yet an angle. Well, it's an equilateral triangle. The angles all add up to 180, and if it's equilateral, they all have to be the same. So you can just do 180 divided by 3, which is 60. So each angle here is going to be 60. So which measurements are you going to put in? Well, you just go for any really, because if you pick these two, we know the angle in between, these two, angle in between, these two, angle in between. So you just pick a set, they're the same numbers anyway. So I'm going to go for this one, and then the 60 in between. So it's half times 8 times 8 times sine 60, and then that will get you the area of the triangle.